All right, algebra kids, moving on to more polynomial operations. And what this actually is here is division. So it's going to be polynomial divided by monomial. Sorry, music got a little sketchy there for a second. Polynomial divided by monomial, and also trinomial times binomial. So we got a whole bunch of stuff to do, and you're like, you just nomialed me to death. I know, I get it. But it's not that hard once you think about what we're actually talking about. This is a great little word cloud here with all your vocabulary in it. I thought that was kind of cool. And this is one of my favorite all-time math meme jokes. So pause it and read it if you haven't already, but I am moving on. Okay, multiplying a binomial by a trinomial. There's two different ways to think about this. We can use the distributive property, or we can do a vertical method. And I'll go ahead and write it out both ways. So what you're going to do with this is you can't FOIL. Think about why you can't FOIL. Well, you don't have a first, outer, inner, and last. What does that make this guy? Extra inner? I mean, there's no way to FOIL, so you can't FOIL. I'm going to discourage you from using a table. I think using a table is kind of silly at this point. We need to get beyond that and try the other methods. That's really just a visual method. If you like it, you can do it, but I'm not going to use a table here. You can either use the distributive property conveniently or do this vertically. So distributive property would mean, so we got x plus 2 times the quantity times x squared minus 3x plus 4. Distributive property would mean x times this entire expression and 2 times the entire expression. So in other words, x times the trinomial, x squared minus 3x plus 4, plus 2 times the trinomial, x squared minus 3x plus 4. And what we end up doing is distributing. So that means x times x squared. Well, think back to your monomial rules. That's x to the first. X to the first times x squared is x cubed. Minus 3x times x. Well, x times x is x squared. So 3x times x is 3x squared. Plus 4x. So that's x times everything in the second set of parentheses. Now we'll do 2 times everything in the second set of parentheses. So 2 times x squared is just 2x squared. 2 times 3x is 6x, so 2 times minus 3x is minus 6x. And then plus 2 times plus 4 is plus 8. Then I can go through and find my like terms. Now in this case, I'm going to have a couple more like terms than I'm used to. I'm used to just having 2 like terms. I'm going to have 2 pairs of like terms. So that means we have an x cubed with nothing to add to it. Minus 3x squared plus 2x squared is going to be minus 1x squared. And then plus 4x minus 6x is going to be minus 2x. With a plus 8 on the end. Okay, and as I said, there's also a vertical method for this. So I'm going to do something that I don't normally do, but there's a vertical method for this. I'm going to, whoa, it got kind of confusing there. Ooh, dizzy. I'm going to zoom into some of the space here. I apologize for the shaky camera thing I'm doing. Or actually, better yet, I'm going to minimize it, and I'm going to do it back here in this empty space. All right, so let's switch colors as well so you can see. So this is, right here, this was distributive property. Good old distributive property. Now we'll do the vertical method. This is going to look a lot like what you were used to when you multiplied a 3-digit number times a 2-digit number back in whatever grade you learned how to do that. Probably 4th or 5th. I don't actually know. That's probably bad. I should know that. But anyway, that's the style that we're going to do. So you're in this problem, you're going to put the trinomial on top, and you're going to put the binomial on the bottom. Lining it up much like we see this 2-digit times 3-digit over here, okay? And what you're going to do is take each of the terms in the binomial and multiply it by the trinomial. Well, that's what we did up here with the distributive property. It just looks different, and as you've seen so far, I am all about giving you options, and so this is just, again, another option. So, 2 times 4, 8. 2 times minus 3x minus 6x. 2 times x squared, 2x squared. And now, x times plus 4, plus 4x. Do you see how this is an analogy over here for what we're doing? Think about it. Write it out the traditional way so you can see what I'm talking about over here. Anyway, I'll keep going. X times minus 3x is minus 3x squared. And finally, x times x squared is x cubed, which I can't fit because it needs to be over by a space. So when I combine like terms, I end up with the same thing as before. X cubed plus 2x squared minus 3x squared is minus 1x squared. Minus 6 plus 4 is minus 2x. and then your plus 8 at the end. And so that's what we get either direction. So please make sure you know how to multiply binomial times trinomial. Okay? Dividing polynomials. So this is actually just going to be polynomial divided by monomial. We'll see more later. So polynomial divided by monomial. That's really all we're going to see here. Okay? What you're going to do is you're going to make 3 separate fractions. Either mentally or on paper, you got to decide what is important for you right now, rather than deciding what you want to do. So I'm separating this out into 3 separate fractions. That denominator can go on all 3 of those terms in the numerator. And I'm going to divide each set of monomials. So 25x to the 4th divided by 5x squared. 25 divided by 5 is 5. X to the 4th, divide off an x, is 4 minus 1 is 3. So 5x cubed. 30x squared over 5x. So we know it's minus, because we have a minus sign out front. 30 divided by 5, 6. X squared divided by x is just x. And then over here, 10x divided by 5x. Well, 10 divided by 5, that's 2, and it's positive. And x divided by x would cancel out. X to the 0 does not need to be written. X to the 0 is times 1. So that's like saying 2 times a 1, but we're not going to write it because we don't need it. And we get 5x cubed minus 6x plus 2. Why don't you take a look at the second one with me? I was going to say, oh, you could do this one by yourself. Nah, let's do this together because it's kind of hideous. 3 separate fractions. So 18x cubed y to the 4th over 3xy minus 27x squared y cubed over 3xy plus 45xy over 3xy. Now I am going to pause it, and I want you to simplify that and then write your final answer. It will be a trinomial. Your answer will be a trinomial. Okay, have at it. Okay, I'm going to pause it and write it out myself. And there you have it. So we have 6x squared y cubed minus 9xy squared plus 15. So dividing 6, dividing 9, dividing 15. X cubed over x. One of them, or 3 minus 1, 2. 4 minus 1, 3. 2 minus 1, 1. Not going to write it. Y cubed over y is 3 minus 1 for my exponents, so 2. And then over here, the x and the y both cancel, and you just get the 15. So this is not a tough one. Expect to see some of those in your next warm-up. Okay, and finally we have what's called the special cases. Squaring a binomial and the difference of squares. So you're still going to treat these as if you're doing the same kind of problem you were doing before. It hasn't changed the method. But I want you to notice something here. This is not the distributive property. This is not distributive. A lot of kids want to make this x squared plus 64 and x squared minus 9. That is incorrect. This does not equal x squared plus 64. You are not squaring each part. No, no, no. No, 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 no. In fact, what you're doing instead is you are still multiplying a binomial by itself. So let's write it out. X plus 8 times x plus 8. We still have to either FOIL, table, whatever. Okay, I'm going to use FOIL because at this point it's getting to the point where that should be a little faster for us. First, outer, inner, last. So first, x squared. Outer, 8x. Inner, also 8x. Well, that's notable. We're going to need to look and see if there's a pattern happening here. And then last. So first, outer, inner, and last, 64. So that's going to come out to be x squared plus 16x plus 64. Now, is there a pattern here? Well, I don't know. Of course I know. I'm just doing that thing where I act stupid and it helps you learn, supposedly. Just pretend that it does. All right, so again, squaring a binomial means x minus 3, the quantity squared. So it means x minus 3 times x minus 3. Again, let's write that out. It's going to be first x squared. Outer minus 3x. Inner minus 3x. Last 9. So x squared minus 6x plus 9. There is indeed a pattern. If you pay attention here, the constant in your answer is the square of the second term in the binomial. The constant in the answer is the square of that second term in the binomial, because even if you square negative 3, you still get a positive 9. The middle term, the linear term's coefficient, is twice as big. as that second term. Okay, now this isn't a pattern, and same thing here, 16, twice as big as 8. This isn't a pattern you can use every single solitary time, but it is a pattern we want to start recognizing. And I want you to remember that this is not the distributive property. Okay, let's look at the difference of squares pattern. The difference of squares pattern, you have two binomials. They're exactly the same two terms, but one's a minus and one's a plus. One's a minus and one's a plus. Let's write this out. So we did FOIL. Let's do this one with the distributive property. X times x minus 4, times x plus 4, excuse me, minus 4 times x plus 4. Okay, and again, my music kind of freaked out here. Let's switch that over to something else. Okay, so x times x plus 4 is x squared plus 4x. As we saw in our previous video, that's what that means. Minus 4 times x plus 4 is minus 4x minus 16. Well, that's interesting, because what's going to happen when we combine our like terms right here? Well, we have minus 4x and plus 4x. They're going to cancel out. I wonder if that's a pattern we'll keep seeing, because this turns out to be x squared minus 16, a difference subtraction of squares. 16 is a perfect square. Interesting. Let's try this one. Okay. Again, we're going to distributive property it. So 2x. Oh, I should have switched colors. That's the pattern I was trying to get at here. 2x times 2x minus 6 plus 6 times 2x minus 6. So that's 2x times 2x, 4x squared. 2 times 2, x times x. Minus 12x, 2x times minus 6. Plus 6 times 2x is plus 12x. Oh, it happened again. And plus 6 times minus 6 is minus 36. So once again, those middle two terms, the OI terms, if you will, O and I in FOIL, OI. All right, they cancel out. And not only this time do we get a difference of squares where the second thing is a perfect square, look at that first thing, it's also a perfect square. So 36 is a perfect square, not negative 36, but 36. It's a difference right here. And 4x squared is a perfect square. It's 2x times 2x. So now you see two new patterns that we're going to practice with on our last slide of the video. Okay, go ahead and write all of this out. I'm going to do the same thing, and we'll go over the answers afterwards. So pause it, please. Try each problem, and then hit play and watch the magic happen. Okay, if you're not going to hit pause, here comes the magic. All right, did you catch that? I went through and wrote them all out with my very strange study music in the background. I even restrained myself from eating a potato chip. There's chips sitting in front of me, and I didn't want all that funky noise on there. So if you're looking, what you noticed here is that I know the patterns. So I don't have to write it out, which of course I should. I'm an algebra teacher. But if you know these patterns, you won't have to write it out. We're going to talk about what those patterns are in class next time. So, having said that, if you have any questions about this page or these problems right here, make sure you write them down, and I'll see you guys in class.